Welcome back. We're getting ready to start Module 7, Lesson 8, our last lesson today, which is going to be Monday's lesson, Monday, May 11th. This is our last new stuff we're learning. Under Wednesday, May 13th, I'll post practice tests, the practice test keys, the practice test videos, and then I have 2 quizzes for you to practice on that I used to give in in-person classes, and I'll make videos for those too. So you're almost there, guys. Last new thing to learn. This is actually a lot of review from our graphing method, substitution method, addition method, and then we're going to apply it to word problems as we go through. So some of this stuff you already know, some of it will be new for you. So solve a system of linear equations graphically, numerically, and algebraically. So here's a system of equations, and we're going to solve it 3 different ways. So the first way we learned is when we made a t-table. Remember, I think it was hot dogs and chips. And we found the point that was in common. So that's what we're going to do now. So when we put negative 2 in, we'll have y equals 6 times negative 2 plus 10. So here's the equation, and here's the x values we're supposed to be putting in. So that'd be negative 12 plus 10, which would be negative 2. And remember, whenever these are lines, which this is a line, y equals mx plus b, there'll be a pattern as long as these numbers are in a pattern, and you can see they're all one larger. So let's just do like 3 of them and catch the pattern, and then we can fill in the rest. So this would be, next is x is negative 1, so negative 6 plus 10 would be 4. And then last, let's do this one, 6 times 0 plus 10. So notice when I had negatives, I had to enclose them in parentheses. But when I have a non-negative, I can just put the times sign. 0 plus 10 is 10. So I can see the pattern is add 6, add 6. So I'm going to add 6, add 6, add 6, add 6, add 6. And remember how I said whenever you use the pattern like we're doing right now, you should always check the last one just to make sure you haven't made any mistakes. So let's put 5 in for that. So we get y equals 6 times 5 plus 10, 30 plus 10, 40. Boom. So we're good. Now we're going to do the next one, and we're going to look for a point in common. So here's the equation for the second one. So first we'll put negative 2 in, so that'd be 2 times negative 2 plus 6, so 6 minus 4 is 2. Then we're going to put negative 1 in, negative 2 plus 6, 6 minus 2 is 4. Then we're going to put 0 in, 2 times 0 plus 6, 0 plus 6 is 6. So here we can see the pattern is add 2, add 2, add 2, add 2, add 2, add 2, add 2. And let's just check 5 just to verify. So 2 times 5 plus 6, 10 plus 6, 16. There we go. So now we're looking for a common point, the point of intersection. No. Ding, ding, ding. There it is. Wow, we found it fast. So once we find one, do we need to find another one? No. It's the only way there could be more than one solution, because 2 lines cross in one point. The only way they could have more than one solution is if one line lies right on top of the other line, which you can see is not the case. So once you find the one, you can stop looking. So the point in common is negative 1, 4. And if there wasn't one, that would have meant the lines were parallel, right? Remember how parallel lines have no points in common because they have no intersection point. Next, they want us to solve by graphing. So we're going to do the same technique that we have done on all of our problems. So we'll do this one first. So remember, whenever we're graphing, we first want to label the y-intercept, which in this case is 0, 10, because it's always a number out here. And then we want to do the slope, which is rise over run. And because that's a whole number in front of x, we want to make it 6 over 1. So when we plot 0, 10, we go, oh, rise 6, run 1. Well, I can't do that. I'm going to be off the graph. So then do the opposite. It would be kind of like making them both negative, because two negatives equal a positive, right? So instead of rising 6, running forward 1, you could go down 6, 1, 2, 3, 4, 5, 6, and backwards 1. And then down 6, 1, 2, 3, 4, 5, 6, and back 1. And remember how I said when you're looking for the point of intersection, you always want to make sure you put as many points in as possible. So down 1, 2, 3, 4, 5, 6 over 1. And I really could have just drawn the points from the t-table, but it's a lot better to practice your graphing, because you're not going to have t-tables on your test on a lot of the problems. So it's better to practice your graphing techniques. So now let's get our straight edge and draw our nice perfect line. And you can verify from your table above the points that are in it. Is -2, -2 on it? Yep. Is -1, +4 on it? Yep. Is 0, 10 on it? Yes. So you can verify that the points that are in the table are also the points we graphed. Okay, next we're going to do y equals 2x plus 6. Remember, the number out at the end is the y-intercept. So first we're going to graph the y-intercept. And y-intercept always has x 0, so 0, 6. And our slope, which is rise over run, again, it's a whole number, so we'll write it as 2 over 1. So 0, 6, rise 2, run 1, rise 2, run 1. I see I'm not going to be hitting the line doing that, so then this one I also have to do the opposite, so you can pretend like these are both negative. So down 2, back 1, ding, 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 there's the point. Down 2, back 1, down 2, back 1. So then I can draw my red line. And again, you can verify that everything's good by looking at the table above. So it says the point -2, 2 is on there. -2, +2, yep, it's right there. -1, 4, yep, it's right there. 0, 6, 1, 8, so on. So you can verify that those are correct. And then remember, when we solve by graphing, we circle the point of intersection, and the last thing we do is write the coordinates of that point. So left 1 would be -1, up 4, so the point of intersection is -1, 4. Is that surprising? Nope, because that's the point that was in common in the table as well. So we're just doing the same thing but using different methods. So table method, which we used on the hot dogs and chips. Then we learned in, I think it was the last lesson, how to graph and find the point of intersection. Now we're going to learn, or do another thing that we learned in the last packet, is how to solve using substitution. So substitution says if you have two equations and they're both equal to y, you learned something in geometry in high school that says if two things are both equal to the same thing, then they must be equal to each other. So to make y equals y, in place of this first y, we're going to put what it's equal to, which will be 6x plus 10, Bring down your equal sign. Instead of the second y, we're going to put what it's equal to, 2x plus 6. So subtract 2x, and we get 4x plus 10 equals 6. So let's go ahead and bring it up here. So 4x plus 10 equals 6. And then we have to subtract 10 because everything without an x needs to go right. And we get 4x equals negative 4. Divide by 4, divide by 4, x equals negative 1. So if you remember from the last packet, once you find one of the coordinates, you go up there and write it down. And then how do I find the second coordinate? X is negative 1. Remember how we said go into both of these? And then that's your check. So let's go into this one, plug negative 1, and let's go into this one and plug negative 1. So we'll get y equals 6 times negative 1 plus 10. 10 minus 6 is 4. Y equals 2 times negative 1 plus 6. 6 minus 2, y equals 4. We got the same answer twice. So that means, yay, we did it right. So now we go over and we put our 4 in, and we say the point of intersection is negative 1, 4. Wow, not surprising because it's there and it's here. So this is called solving the system numerically. So that means make a table, look for the number in common. This is called solving a system graphically, and this is called solving a system using algebra, specifically the substitution method. But notice they all yield the same answer. You use of the three, this last one the most, because on these two, if the intersection point was 1.73 comma 2.58, would have been really hard to find on a table or on a graph. Using algebra, though, it doesn't matter what your numbers look like. They're all about the same to find. So this is the most popular of the methods just because it's exact. We can't do fractions and decimals too easily with tables or graphs. Okay, let's see what's on page 2. Oh, something exactly the same. So I'll tell you what, why don't you guys shut off the video and go ahead and do this one now that you've seen one in play and you know all the different pieces, and practice. Okay, I'm going to go ahead and go. I got about a minute and a half, so I'll get a start. So this one, x is negative 2, so we have 4 times negative 2 plus 1, so negative 8 plus 1 is negative 7. Next I'm going to put negative 1 in, so 4 in place of x, negative 1 plus 1, so negative 4 plus 1 is negative 3. 4 times 0 plus 1 is 1. So it looks like we're adding 4, adding 4, adding 4, adding 4, adding 4, adding 4, adding 4. And we'll go ahead and check 5 just to verify that it's correct. So y equals 4 times 5 plus 1. Should be 21. Yes, it is. Yay! Okay, let's do the next one. So this time we're putting negative 2 into this. So 4 times negative 2 minus 2, negative 8 minus 2, negative 10. 4 times negative 1 minus 2. Negative 4 minus 2 would be negative 6. And 4 times 0 minus 2 is negative 2. So again, it looks like we're adding 4, adding 4. So in the next video, we'll finish that.